My name is Anuj Goyal, and today I am presenting my project titled Optimal Inventory Control System for Machine Spare Parts and Consumables. In many industries, machines require spare parts and consumables to operate continuously. Traditionally, inventory management methods such as manual records or spreadsheets often lead to stock storage, overordering, and production delays. To solve this problem, I developed a web-based inventory control system that helps organizations to track spare parts, manage suppliers, monitor stock levels, and automatically optimize inventory using the economically order quantity EOQ model. The goal of the system to reduce downtime, improve stock management, and support data-driven decision control. Now I will demonstrate my project SpareCo, an optimal inventory control system for machine spare parts and consumables. Now here is the login page. If a new user is come to our website, then he has to sign up. Now I am signing in this website using the already existing credentials. After the successful verification, it will redirect to the main page. Now this is the main page of my website, in which it shows the stock level graph. Here is the showing the process bar. There is a timing chain, one spare part, 67%. It is optimal. If a stock, if a spare parts is not optimal, then it will show the low level stock. So we have to reorder it. Like this showing the critical action. Now low level stock level alert. Now we have to reorder it. Now come to the our first feature in EOQ computation, tools and precision control, which EOQ computation, which calculates the optimal order quantity that minimize total inventory cost. Next come to the reordered point analysis, which automatically determine when a new stock should be reordered based on demand and lead time. Now come to safety stock planning. The system also supports safety stock planning, which helps maintain buffer inventory to prevent stock outs during the demand fluctuations. Now come to the ABC VED classification. Another feature is ABC VED classification, which classifies spare parts based on their value and operational criticality. Now the total cost minimization. Another finally critically and lead analysis help identify vital spare parts that require priority procedure. Together, these modules all make a complete analytical framework for spare parts and management. Here, the system provides a different inventory management model that organizers can use depending on their operational requirement. For example, the economic order quantity model calculates the most efficient quantity of item to order in order to minimize ordering the holding cost. The formula is used here is a Wisdom EOQ formula, which is shown in the website, which considered annual demand, ordering cost, and holding cost. Now we can take an example by calculating the EOQ cost using a calculator which is available in our website. We are first input the annual demand, unit cost per spare part, holding cost per spare part, holding rate. Now it will calculate the EOQ of the optimal inventory spare parts. Now come back to the our website. Now this page is used to manage our machine network. Like a country, industry wants to operate their machine from one place. So now he can register their machines in which city it will operating. Now I firstly now add the machine on database or website. Let me take a name, test machine 1, which is operated in Agra. We can set the status if it is maintained or decommissioned or active. If you click on the register machine, then it will registering on our data on our website, so we can easily track it. If we want after the work after the completion of work, if we want to delete it, then we can easily delete machine and it will automatically delete easily. Now come to this manage spare parts and suppliers. This page manages spare parts and suppliers. On the left side, user can register new spare parts by entering details such as spare parts name, part number, machine category, and unit price. The right side of our website displaying the registered suppliers by adding the details like company name, contact person, email address, and phone number. Now I will demonstrate these function of my website. If we want to register a new spare part, then we have to register a new spare part. If we take a name, valve, it is the use case of this valve. We register a new part and it will show here. Here we are adding a new spare part, so we have to reorder it. I will demonstrate this part also. First we have to I will demonstrate you a register supplier column. Like if we want to register a company, Bagel and Sons, contact person, email address, phone number. When I will click on the register supplier button, it will register the supplier and it will display under the active supplier directory. Like I registered the Bagel, it will be here. Now I will demonstrate you the live reorder process. Firstly, we have to click on the reorder button. Select the supplier from where we want to take our products. Enter the quantities and here is the price of these all the quantities. When we are clicking on the submitting button, then it will be redirecting to our the payment page. Now click on the payment page. After the successful payment, the order will send to the supplier. Then he has to deliver to us, and it will redirect this to our main page. Now the stock is ordered, so it will display in our the active purchase histories like display here. If we want to confirm this order, then we have to mark received. If we want discard or refund, if we click on it, then it will be refund. It will be cancelled the order and the refund will be initiated by the supplier's end. So if I click on the mark active mark received, yes, confirm, and it will update it here. The stock is okay, 100 by 10 means the bare minimum stock is at 10. Then we order 100 stocks, so the stock is available in our website. If we want to edit the price of the unit price, then we can also edit it, and if we want to delete it, then we can easily delete this like this. So it's all about my project. In the conclusion part, this project demonstrates a smart inventory management system and machine spare parts. It integrates inventory optimal models such as EOQ, safety stock, and reorder points. Analysis with modern web technologies, the system helps organizations improve inventory efficiently, reduce cost, and minimum machine downtime. Future improvement could include AI-based demand prediction and IoT integration for the automatic inventory monitoring. Thank you.